Hello, everyone. We are at the top of the hour. So this is session 5 of 5, and actually our last session in our webinar series, focusing on the balanced mix design in quality assurance. Our speakers, Tim Aschenbrenner and Derek Neerplant from the FHWA, will cover key challenges and considerations for integrating balanced mix design tests into production and quality assurance process. Before we get going, I would like to go over a few housekeeping items. If we can go to the next slide, please, Tim. There you go. So throughout the webinar, please keep your microphone muted. And if you have any questions during the webinar, go ahead and post them in a chat box, which you can access by clicking the chat in the meeting controls. I will compile the questions throughout the webinar, and the presenters will address them at the end of the webinar as time allows. If there are any unanswered questions due to time constraints, we will be responding to those questions separately. And this webinar is being recorded, and the link to the recording will be provided at a later time. We will post the link on the website. So as I noted, this is our final webinar in our 5-part series focusing on quality assurance. Just to give you a quick recap, our first and second sessions covered BMD implementation planning and validation. The third session in April focused on specimen fabrication, where we discussed strategies to reduce variability in BMD testing through consistent and standardized lab practices. And the fourth session in May addressed testing conditions critical for reliable BMD outcomes. Links to the recorded webinars are shown here on the slide, and I will include them as well in your chat box. So you can go back and then listen to those webinars. Before we proceed, I would like to share the following disclaimers. This material is disseminated under the sponsorship of the U.S. Department of Transportation in the interest of information exchange under the cooperative agreement number listed. The U.S. government assumes no liability for the use of the information presented. Except for any statutes or regulations cited, the contents of this presentation do not have the force of law and are not meant to bind the public. This presentation is intended solely to provide information on existing legal requirements and agency policies. The U.S. government does not endorse any products or manufacturers. Any trademarks or manufacturer's name mentioned are for information purposes only and do not indicate preference, approval, or endorsement. References to AASHTO or ASTM standard in this presentation refer to private voluntary standards. Compliance with them is not required under federal law. We do have a slide for you with acronyms and abbreviations that will be used throughout the presentation. I will pause for a moment to give everyone a chance to quickly review them. Very good. Now, before we begin, let us briefly go over the expected outcomes of today's webinar. By the end of this session, you will recognize the current challenges in incorporating balanced mix design into quality assurance program, understand the purpose and importance of quality assurance systems, identify available options or strategies for integrating balanced mix design into production and quality assurance process, and emphasize the need to measure and maintain consistency in asphalt mixtures, even when using balanced mix design. So these key takeaways will help guide today's discussion. and provide a good foundation for implementing balanced mix design effectively. With that, let's get started. I will now turn it over to Tim Aschenbrenner to kick off the presentation with quality assurance background.
Well, thank you, Ellie, for the introduction, and welcome everyone to today's webinar. I'm glad you're able to make it, and I hope you get a lot out of it. If questions come up, don't hesitate to pop them in the chat, and we'll address those at the end. I'm going to start with the first of the four sections here, do a background on quality assurance. Uh, Certainly supporting quality improvements is a good thing at FHWA, and I'm sure many of you here want quality to improve. We certainly want to support and encourage that with all the innovations out there. For example, balanced mix design, one of the background reasons for the webinar is a quality innovation. There's emerging technologies like the dielectric profile system and other non-destructive testing technologies. But as we support and encourage these, we also need to support and encourage the production and staffing efficiencies that go with it. We want to do a good job with implementation, and also, probably even more importantly, public funding accountability remains. When we do this, we want to be good stewards of the taxpayer dollars, and by doing that, we want to rely on the fundamental quality assurance program, those fundamental acceptance principles. And we'll cover some of those here in the background. Risk management is where we'll start. Certainly testing and inspection is important. We can certainly minimize risk. The more and more we test, the more and more we inspect. But there's a limit. We can't inspect and test everything. And so we need to look at this from a risk perspective. Materials quality risks are often looked at from a contractor's perspective as having good material rejected. That would definitely be a risk. Agencies see that as a risk if there's poor material accepted. That's certainly an unacceptable risk. And to manage those risks depends on a few things. One is the amount of testing. Ultimately, the thing that minimizes both of those risks is more and more testing, but there are limitations. The amount of testing is often determined by variability. Variability comes in multiple locations. We often call this inherent variability, the four components. That material may look like it comes from the same aggregate source, but not all the aggregates at that source may be exactly the same. When construction processes go on, variability can be increased or decreased. And that photo, we're seeing some fractionation occur, which will minimize some of the variability. Sampling certainly introduces variability, and testing does as well. The four of those have a composite variability. And when we start looking at balanced mix design tests have more variability than the traditional tests we're looking at. So that inherent variability from testing is going to increase, and that will impact the risk as well in terms of the contractor and agency risk. So as we get started here, we're going to use some national terms. The national terms are from AASHTO R10 and then the TRB circular. These two documents have been harmonized, so the terms in each one are the same or similar. Very commonly, as you go from state to state, they have their own terminology, particularly in the quality assurance arena. You almost need a thesaurus to understand what some states are talking about. It takes a while to learn, but we're going to rely on the national terms for this effort. And as we get started, we'll be reminded of the 6 core elements of a quality assurance program. Mainly today, we're going to talk about the role of the agency in terms of acceptance and the role of the contractor in terms of quality control. But even though we'll focus most of our attention there, we certainly want to remember the other 4 key elements of quality assurance: the independent assurance, dispute resolution, the personnel and lab qualification. And those 4 elements really help minimize variability, which is vital for the agency and contractor's role to be as effective as it can. So we'll start with agency acceptance, often called verification sampling and testing. This is defined in our Code of Federal Regulations, and it needs to be carried out by the agency or the agency's designated agent, which is another word for our consultant. And the agency needs to independently perform inspection, at acceptance testing, or what we sometimes call verification testing. And ultimately, the agency is the one responsible for measurement and payment. Only the agency makes that determination. Now, the agency also has roles in terms of overseeing the contractor. The contractor has a quality control plan, and it's incumbent on the agency to verify that the control plan is being followed and how that control plan is producing results. And if we move to the TRB e-circular, we see acceptance is a process whereby all those factors include sampling, testing, inspection. So acceptance is all those factors leading to the degree of compliance with the contract requirements. Now, in parallel, if you will, to the agency's efforts, the contractor also has an effort going on with quality control. They'll have their own materials sampling and testing, frequency schedule. They'll do their own visual inspection. Now, in some areas, not everywhere, but in some areas, contractors' quality control tests can be part of the payment decision. If that, in fact, is the case, the contractor's tests and sampling need to be independent of the agency. The contractor and agency tests need to be validated. Essentially, what that means is there has to be a mathematical comparison between the agency and contractor tests to make sure those results are the same or similar. And then the contractor has to have qualified technicians and laboratories. And then the contractor also needs to be part of the independent assurance evaluation. If we look nationally, based on our most recent quality assurance assessment for asphalt pavements, we see probably over half the states, just over half the states, allow contractor test results to be used as part of the acceptance decision. Next, we'll talk about mixed design. And in mixed design, there's two components, the mixed design approval and the mixed design verification. And both of these are really essential to ensure that that asphalt mix meets the expectations of the agency and contractor. Going through this process, make sure when full production starts that we'll have the material that meets the requirements. So let's first look at mixed design approval. So mixed design approval is before production begins. And we're looking to see if this mix meets performance criteria. Now, more often than not, it's the lab mixed, lab compacted material, but sometimes states allow or accept plant mixed, lab compacted material. This material might have been produced on a commercial project. It might have been produced by the contractor as a hot drop that ultimately might end up in a wrap stockpile. And the agency approval process can usually take one of three forms that we've seen as we've looked around the country. One is a paper review. Agency will look at the contractor's results on paper and see if everything passes. Another one is full lab testing. An agency may decide they're going to do full lab testing and check every test and test result that the contractor provided to see if they match. My personal favorite's the one in the middle, where there's physical lab testing of a few critical properties. So an agency there would do a paper review for most of the information, but then take time to run physical testing on some of those tests that take longer, like the ignition furnace correction factor, or perhaps the bulk specific gravity of the aggregate. But they're all approval processes that are used around the country and certainly all acceptable. So now as we move from mixed design approval to mixed verification, We see mixed verification is definitely produced at the plant. Here, the contractor is producing the material from the actual plant, delivering it to the actual project to make sure that the specifications can be achieved. So it's plant mixed, lab produced. More commonly, it's done as a test strip on the project. Some states will say it has to be done on a shoulder, or some states still will say that it has to be off of the project as a hot drop, or perhaps material that was produced for a different state project or even a commercial project. And then for the verification process, the contractor's responsibility is to produce the material from their plant and place it. And then the agency does the testing. And based on the agency testing, the mixed design can be verified. So as we go through some of the QA basics, as we're looking at measuring quality, quality characteristic is really where we start. Quality characteristic is a specific material property or a test result that we get. It could be an asphalt content, it could be an in-place density. You could run an ideal CT and get a CT index, but those are all specific material properties that we call quality characteristics. These quality characteristics are attributes. They could be for quality control, which is a quality control quality characteristic, or they could be for acceptance. They could be an acceptance quality characteristic. And these quality characteristics are selected by agencies to put in their spec because they relate to initial and/or long-term performance. Some studies have shown that, and so states feel comfortable specifying that. There's tests that give you a measurable, quantifiable test result, and it can be reliably measured over and over. So the variability is known. And then these quality characteristics can be applied in a couple of ways. An agency may use these quality characteristics for payment or price reduction. In that case, the acceptance quality characteristic would be driven to assess the pay factor. Or these acceptance quality characteristics can lead to action or suspension limits. For example, it could be a go, no-go situation, in which a contractor would have to make adjustments before continuing to proceed with paving. If we look around the country from our most recent quality assurance assessment that we did in 2022, we see things like in-place density, air voids, binder content, smoothness. Those three quality characteristics, more often than not, a majority of states use those quality characteristics as a pay factor. Although in a few cases, some states use those as actionable limits in which they might want go, no-go to occur. Now, at the other end of the spectrum, if you will, we see mixture performance tests. A vast majority of states that use those are using those as production control. So those quality characteristics are used as actionable limits, but not necessarily for pay, except although we see 3 states use them for pay. And then voids in the mineral aggregate, that's got a nice split there, and about 3-way split. About a third of the states don't use VMA. About a third of the states use VMA as an actionable limit, and about a third of the states use VMA as part of the pay factor decision. So as we move on from the quality characteristics, we have to apply specification limits to quality characteristics to define what is satisfactory and what is not. So in-place density, very commonly, we might see a minimum 92.0. Sometimes there's also a maximum with in-place density. Asphalt content often has a target, and that target has tolerances, plus or minus, applied to it. And since this is a balanced mix design webinar, CT index might have a specification limit. Usually that would just be a minimum. Now, along with specification limits then come with acceptable quality levels. And this is where we are running these quality characteristics sublot per sublot. And then when we get an entire lot's worth of test results, 4 or 5 or 7 test results for our lot, we then analyze that lot to see if things are acceptable. And if a quality measure, for example, is percent within limits, and a good example is 90% within limits is considered the acceptable quality level. I mentioned quality measure, and quality measure is that level of quality of a quality characteristic. It can be an average. Sometimes we see lot average being used. Sometimes it can be variability. Sometimes it's average and variability. For example, percent within limits uses both average and variability. But ultimately, the quality measure gives you a number. It's a numeric representation of quality. For example, 90% within limits, or you could have a lot average of 93.5. If you look around the country from our most recent quality assurance assessment, we see just over half of the states around the country use percent within limits for asphalt mixtures. Now, part of the acceptance plan, a key part for acceptance is random sampling. Here, we want to make sure all the material produced on that project has an equal probability of being sampled. We want to remove bias and reduce fraud. Random sampling for the agency and the contractor is very important. We highlighted a need to emphasize this with the publication of 2 recent tech briefs. These are available on our FHWA website. One's on asphalt mixture sampling, and the other's on random sampling and sample security. And with all the turnover in the industry, we can never emphasize the importance of this enough. Well, once we get our quality characteristics tests lot by lot, we analyze our sublot by sublot. Once we analyze those sublots into a lot with our quality measure, we're going to start looking at pay factors and price adjustments. These often take the form of disincentives as well as incentives. Now, disincentives recoup losses from those unexpected poor quality work. So if a material might just barely fail our specification limit, we don't want to remove and replace that. We can accept that material at a slightly reduced price. In fact, rejection and removal is rare, so having these disincentives to account for marginal material is very, very common. But also there can be incentives. Incentives can reward increased performance. Those quality measures that go above and beyond the quality measure that was determined to be acceptable can be rewarded with an incentive. Now we want to make sure our quality characteristics relate to performance, and because that will help motivate improved quality. And we've seen incentives have the ability to encourage innovation, and many contractors that know they can meet incentives will compete more favorably in a low bid environment because they'll be better able to come up with their bid prices. So as an example of an acceptance plan or a pay equation, here we have the AASHTO, what we call the AASHTO pay equation. It's out of AASHTO R9. We'll start with the acceptable quality limit. Here we see the percent within the limit of 90% matches up with a pay factor of 100%. Now, if a contractor were to get more than 90% within the limits, an incentive up to 5% could be awarded. However, if the contractor were below 90%, then that would equate to a disincentive. Up to a certain point, we have a rejectable quality level. At this point, at 50% within limits, that's deemed to be no longer acceptable to remain on the project. And at a 50% within limit, that rejectable quality level would call for removal and replacement. We certainly prefer the linear pay program as opposed to steps for various reasons. So in summary of the background of the key points, we talked about the 6 core elements of quality assurance. The main focus you've seen here is on the role of the agency in terms of acceptance and the contractor in terms of quality control. But don't forget the importance of the independent assurance and dispute resolution, the importance of the lab and personnel qualification, because those really help minimize variability. And as we start measuring quality, we start with those quality characteristics. They can be used for quality control or acceptance. They can be used for pay, or they can be used for action. A lot of options there. But when they're set, we want to have a specification limit identified and an acceptable quality level identified so that when we calculate the quality measure, we can figure out the appropriate actions. And then for that acceptance plan, random sampling is very important. And then that leads to pay factors and price adjustments. And with that, I'm going to turn it over to Derek for the next portion.
Thanks, Tim. Appreciate seeing all the familiar names here on the webinar today. Good to be with you all. I'm going to take us in the next part of this presentation and talk about where in the tasks for implementing balanced mixed design do we start getting into these quality assurance items. And just a couple notes as I kind of take over from Tim. First of all, that last 20 minutes, if you ask me, in my opinion, everyone should hear that every year that's doing that, right? These basics of quality assurance that bring us back to why are we doing it, right? We're at the point now where some specifications have been there for such a long time that we need to remember why we're doing all these activities. And the programs look different, as Tim noted, in all your different states, your agencies. But what is each activity and what purpose is it serving? So now I'll try and cover a little bit of when you're developing specifications, there's kind of a difference now that we need to differentiate between what Tim talked about as mixed design approval or verification. And now we're talking about quality assurance. How does that change the game, if you will? So we'll show our table here that you've probably seen. If you haven't, then I don't know where you've been. If you're talking here, but we have our 8 tasks and the numerous subtasks here. And the source is there for the tech brief for your light reading, of course. And these are the tasks to put BMD implementation. Now, again, at the onset of this, it was primarily thought as mixed design, right? Balanced mixed design. Well, it's come to the point that people now want to get it to quality assurance. So now we got to start thinking about these in that realm. And so the tasks that we find ourselves kind of thinking about this integration into quality assurance the most is task 6, specification and program development. It's more than just writing a spec. It's developing a program. And how do those tasks relate to going beyond mixed design? Going beyond just approving a mixed design before a project. Well, now we want to do quality assurance in some way, bring it into the production environment. All right, how is that going to change things? What added tasks need to be accomplished in order to do that successfully? So where we find is for specification development and program development, if you will, because again, as Tim mentioned, quality assurance is more than just a specification. There's a couple key things that need to happen in order to bring it here, right? Number one, criteria. Having some established preliminary criteria for whatever your balanced mixed design mechanical testing is going to be, by mix type, by roadway type, however you happen to be doing it. So what needs to happen in order to make that happen, right? We need to have some sort of field validation experiment or forensic investigation. We need to justify that criteria with real world performance in some way. If you missed the earlier webinar on that, please go back and watch that. An incredibly important topic that definitely needs to be thought of and is going to come up. The strength of that is going to be very crucial to have success of bringing it into a quality assurance environment, now paying on this. Other things that need to happen beyond that, right? Variability studies, which is talked about earlier in subtask 4.5. You need to know variability, as Tim talked about, right? Those 4 main sources of variability. These are going to be different, right? And it has been shown to be far different than what we typically use in a quality assurance environment today for much of things that we pay on, etc. Okay, if you think about the typical testing variability, right? Sampling and testing variability that we have to assume in a measurement of asphalt content by ignition or by extraction compared to the value itself, right? A couple tenths, 2-3 tenths out of 4 to 5%. Right? We're talking about, with balanced mixed design, coefficients of variation 20%. It's a completely different scale there. So it's something that's going to have to look different, be a little bit different, and be handled differently to be successful. So variability, you got to know your variability. Know, again, not just testing variability, but also production variability. How do things that happen in production vary? That's not necessarily going to come from just lab produced mix. So that's where that baseline data in task 5 is also important. Many agencies may have started looking at balanced mix design with just lab produced mixes. That variability is not going to be incredibly helpful for you if you're trying to bring this to the production side of things. So gathering data of what does production variability look like under current conditions, right? Those type of things are going to be incredibly important. And so considering a given agency, a state DOT, you have an existing acceptance program. And Tim talked about and highlighted some of the ways that that differs across the country, right? Some use just the agency testing for acceptance. Others use contractor data in the acceptance decision. That's a big difference to consider. What is that going to be incorporated into your balanced mix design implementation or not? That's going to change things. All right. Some of the other items about sampling, where does sampling occur, etc. How is it done? All of these things are going to play into what does BMD quality assurance look like for you. Okay. So given that existing acceptance program, what you're really tasked in doing is identifying your quality characteristics. What are my quality measures? So as Tim talked about, how we take that data, do we average it? Do we make a percent within limits? Do we, et cetera, et cetera? And then making spec limits, right? So as we have highlighted a number of times, and I just continue to steal from Tim over the years here, but if you take something like VMA, voids in the mineral aggregate, just saying your spec and if you have one, if you are one of those states that do pay on it, right? And you have a number, that number is only meaningful if you know the rest of the story. If I say this state is a minimum 14% VMA, well, you're going to answer a bunch of other questions. Is it average in the lot? How big is the lot? Is it percent within limits, right? All of these different things matter. The same thing is going to be if I say, oh, my state's doing a minimum CT index of 100 in production. That really doesn't tell you all that much. It's all with that other context in order to understand it. So that's all got to get figured out. And then certainly risk analysis to evaluate your preliminary criteria. There's an effort to balance risks between the producer, right, and the agency, the owner, okay, and balance those in a way that works, that we do with any other balanced mix design is not going to be different. We're going to look to analyze that risk when we make an acceptance quality characteristic and all the rest of it. Now, this I've talked about in the context of acceptance. This could also be applied to quality control. We always kind of think, people I find think quality assurance, let's talk about using it for acceptance, right? For pay, that's what matters, right? Quality control is just as important, is an important function done by the contractor. These type of things need to be there on the contractor side for QC as well, whether or not it's an acceptance or not. So that's another way to approach this, as has been done with other items in the past, is maybe bring it into QC first before jumping right into acceptance. But these are the type of things that need to happen. Another just set of caution, this might be the third or the fourth time we have shown a slide similar to this throughout these webinars. But a big item that always comes up with balanced mix design is setting the criteria, right? We're going to use X test. How do I pick the number? How do I do that? Where do I get that from? And obviously that's a critical item. It requires input from a ton of other things. A lot of those other tasks that we always talk about feed into the idea of what criteria am I going to set. Doing your homework, looking at what other people have done, benchmarking what you have today, looking at your pavement management data, looking at production variability, right? If that criteria is going to be used in production, because you have to live in that production world, among others. You've collected all that information. Now it's time to set it up, right? But again, caution with using and just looking at others. Again, my example stands there, right? That you could look at, someone says X state has a minimum CT index of 100. Well, I have 10 questions to follow that up to get any meaning from that. Is that lab produced or is that plant produced? Was that based upon lab samples or plant samples, right? Okay, how was that validated necessarily? right? If they're doing it in production environment, is that specification based on an average lot? Is that a single test? Is it a statistical spec, etc.? Forget all those other things in the blue box there. It's talking more about validation, about differences between states, climate, mixed types. But you see, quality assurance programs is a bullet there, and that's very important. There's just very key differences if we try and take two states that are both moving towards balanced mix design, and one has a system where they do, say, centralized testing, acceptance, and they use only agency results, versus a state that uses contractor results and they have labs out at the plant. All right, at each and every plant, and they have staff testing there. Those are two wildly different systems. So we need to understand how that feeds into the rest of the specification and what you're looking to do from a quality assurance standpoint. And so part of this, one of the tasks that we talk about, that if you're going to bring this into the production environment, you need to start to develop sampling and testing plans. There's some existing guidance in AASHTO R9, right? Balanced mix design doesn't throw any of that out, right? Of any of those principles of quality assurance that Tim talked about. There's consideration to identifying what's your location and method, what's lot and sublot sizes. But a key reminder, and let's put this in the context of balanced mix design testing, right? Okay, we're often going to need more material than we have before, versus if I was going to run a couple rices, a couple asphalt contents, maybe, you know, do some voids, etc. Versus if I'm going to run CT, RT, plus maybe some of those other tests, we're going to need more material. All right. Location matters because of the whole idea of reheating, aging, and we're going to talk about that when we talk about lessons, right? How does that feed into this? We've worried about that with volumetrics. People have been concerned about reheating and its effect on volumetrics, or how long the testing took, or conditioning. But our concern, or the amount of effect that it's been shown to have on the results, is much higher versus what we use today. And then lot and sublot sizes are so important because they directly impact the reliability of the acceptance decision. Okay. So just a very crude example that if you don't live this from day to day, you're a producer, right? You're going to produce 10,000 tons and you got two different specs standing in front of you, right? One says we're going to sample every single truck. We're going to test every single truck. You'll know what you produced if you sample every truck, but how much testing will you do? How much time is that going to have to take as an agency or an owner that's testing? You have a very good handle on what you received as a product, but it'll take a ton of effort, right? Versus the other side, let's go completely the other side and say, you know, 10,000 tons, I'm going to take one sample and I'm going to decide whether I'm going to pay you or not. All right. The risk situation and the reliability of the decision is vastly different in those two obviously extreme examples. But to show that, you know, sublot size isn't just about it's certainly impacted by agencies and contractors, your resources. How many people do you have? The lab, the throughput of the lab, etc. Testing time is a major factor there. But we have to understand that when we make compromises there or make decisions there, it's affecting the reliability of the decision, and that there's risk to the owner at times, there's risk to the producer at times, depending on the spec and the reliability of that. So we need to understand that, do some analysis of that to make sure that we're balancing risk as best as possible with not only the sublot size, testing frequency, etc. Again, another key point here is that often people will use some sort of initial production sample to verify properties at the beginning. Right? Many agencies, we'll hit on this a little bit later, they'll do this because balanced mix design has shown that things that our industry has taken maybe for granted with our current systems, we can't with balanced mix design. A perfect example, PG supplier, right? PG binder supplier or source or whatever you want to call it. If it gets approved in a mix design 6 months earlier, is that going to be the same binder that shows up on the job? It'll be anything but, right? It'll be anything but the exact same thing. And that's shown to have differences. You could say the same thing with wrap and other things. All right. So that's where the need for production shows, but we also have to consider those challenges when we're putting this into practice. Other thing that we talk about in the tasks is pay adjustments. I think a lot of people want to jump to the pay adjustments, right? How do I pay based upon this? So it's not a goal for many at this point. It's kind of maybe a later thing. And we find in general, as we're talking to agencies, that most agencies are looking at, maybe not putting BMD into production right now, but it's an eventual goal, et cetera, that they might get here. But it is kind of the goal, if you step back, of a performance specification, is to say, well, if this test matters, can I just pay on it? Right? I pay if it's good, I don't pay if it's not, etc. So conceptually, it makes sense, right? But in order to do this, we need to find a way to rationally defend a way that relates pay to that quality characteristic that relates to expected life in some way, shape, or form. We do that today with what we have. And what we're saying is, what we're hoping is balanced mix design, these mechanical tests and their properties are an improvement upon what we have. But we do have to deal with the variability, the added testing time, all those things, right? It's not just going to be a cut and dry, just sub them in. So developing that needs to be rational. Again, something that having validation efforts would be very useful to have, because then that can be defended. All right. And then if you're going to do that, you select your acceptance quality characteristics. What am I going to accept on? Right? Distinguish that from, say, production control, which Tim showed earlier, right? You can have things for production control, but you're not paying on them necessarily. So this could include a mix of traditional mixed properties and then mechanical test or surrogate. Why? And the why might be because to get to pay adjustments, you do want a couple things. You want good acceptance quality characteristics that relate to life, right? We want the greatest high that we can get. We're still searching for that number that's going to tell us the life, that I test it and it tells me what the life is going to be. We don't have that, right? So we're looking for stronger ties. But we also want to encourage consistent production. The way I often look at this is we do a lot of testing in that mix design approval and verification process because I want to know whether the mix is going to be good. I'm putting extra effort in the beginning of the project to approve this mix to give me the confidence that it's good. Now we get to production, my focus somewhat shifts a little bit, at least how we've traditionally done that, is am I getting the mix I expected? I've kind of decided this mix should be good. Am I getting that mix in production? And you want it consistently. Again, tenets of quality assurance have found that variability contributes to failures on our roadways. That variability, that lack of control, a lack of consistency will lead to failures. All right. So having a measure that uses realistic and achievable variability and knowing that is important. And then making sure that you have some sort of well-supported way to justify your pay adjustment. It's not just thrown off the wall, right? We can't have something that's way too high, way too low, right? That's not going to balance those risks. And it's all about balancing those risks. So where you get to is, as a task, developing pilot specifications and policies. And this is the point where we hear agencies kind of talk about, well, I'm going to put a pilot spec out, we're going to do it in production, et cetera. And there's a lot of things that need to get you prepared for that. But it's a compilation of what you see on the screen here for bullets. So this is kind of your almost checklist. Do I have this? Have I figured this out? Or at least have a starting point? What are my acceptance tests going to be? What are the quality characteristics I'm going to accept on? I would even add on, right? Or go into the bullet to the side. Am I using contractor data in the acceptance decision? And how am I validating that? Right? That's only as good as the validation process. Then finally, the measures, average, single test, etc., specification limits, all dependent on the sampling and testing frequencies. What's required for QC? Often we breeze right past that and just jump to acceptance, like I said earlier. QC is a good tool to start with some of these things, right? Have the QC testing be able to do this, right? And then finally, payment determination. That is as close as you're going to get to the full story of what an agency does. And Tim's going to show this in a moment of what some agencies are doing with balanced mix design testing in production. And you'll see elements of this, right? Not all of it. It's a long story to try and tell, but think about all of these things being necessary, a compilation of that. That's your pilot spec and your policies. that will then get altered over time as you learn things about how this is working in your system. And the kind of final note here just to think about is Tim again showed this graphic. We've shown it many, many times. We always talk about agency acceptance and contractor quality control. Those other 4 items need to get adjusted accordingly as well. If I start bringing this into acceptance and I'm paying on BMD, it's now got to be handled in independent assurance, dispute resolution, personnel qualification, lab qualification. We talked about that in task 7 about kind of training and certification. But that can't just wait behind. That's got to come along with it. And once we promote it to that level and use it for that purpose, we've now got to make sure that these programs incorporate that quality characteristic, that test, into their individual programs. And so just to give you an idea what this looks like overall on a project, in this step A here, we see that BMD mechanical tests, certainly people are using it in mix design in the lab, all right? They're using it to approve a job mix formula or a mix design, all right? And maybe that's starting to get a plant-produced sample like Tim alluded to. But now we start in step C, well, a QC plan. That could be the next thing. Incorporate it into QC. It's not yet for payment, but somebody is testing it on a frequent basis to see how sampling, testing, how does it vary, etc. You could also get into doing something starting on initial production. We mentioned that earlier. That's not quite using an acceptance yet, but it's bringing it into the production environment. So this could be a control strip, a hot drop. You're doing the real mix. You're using real mix that's going out on the road, but it's not your everyday quality characteristic necessarily. And then finally, you get to the right, okay? And then you have the idea of I'm using it to approve in full production or using it as a quality characteristic. But even that has levels, like Tim talked about. It could be used as production monitoring, not tied to payment. Maybe a go, no-go, or something that's watched during production, but not necessarily tied to full payment procedures. Maybe there's surrogate testing that could be related to it. And then finally, bringing it down to pay factors. But I guess what we try to illustrate with this slide is there's many ways to incorporate it into production. Doesn't necessarily have to jump right to payment right away. And so with that, I'm going to give it back to Tim to give some examples from other agencies and what they've done so far to kind of show what the variety and choices are out there.
Yes, thank you, Derek. I'm going to go over some strategies and case studies that we've seen some states implement. We certainly always want to encourage quality improvements, and we know this is very early in the process, and we applaud states for making steps in this direction. But we'll look at some of the case studies, knowing that things can always evolve. And I'm going to go over mixed design approval, mixed design verification, and then also acceptance. And what I did is I looked at 6 different states. And as you can imagine, whether it's the process of mixed design approval, the process of mixed design verification, or the process of mixed acceptance, these processes have many, many steps, maybe 30 steps. As you're well aware, states are very thorough in how they go about all those steps. And if I was going to go through all of these steps, it would take a very long time and get very detailed or very specific to a state. So what I did is I just pulled out 4 or 5 key decision points to look at that could serve as an example to a state that might be looking at implementing balanced mixed design and quality assurance. I think the other point I want to make is quality assurance is all those planned and systematic activities that lead ultimately to acceptance. And mixed design approval, mixed design verification, that's part of your quality assurance program, just like acceptance is. So as we start off, I had mentioned 6 states, but here I have 5 listed because 2 of the states were very similar. And so we look at these 5 states. For sample location, we see almost every state is using that lab mixed, lab compacted material. Now, a couple of the states also allow plant mixed lab compacted material. That's based on the contractor's preference. One of the states uses lab mixed, lab compacted for the volumetric properties, then plant mixed, lab compacted for the mechanical properties. Now, one of the things that goes along with mixed design is relaxing specifications. There can be volumetric criteria. There can be constituent criteria related to aggregates or binder. And the more confidence you have in the mechanical tests, the more you might be able to relax the volumetric or constituent properties. So here we see two of the states did relax nothing. State 2 is only using the Hamburg only, so certainly that makes sense. Another state is not relaxing anything, but they're still trying to gain confidence in not only the test, but the contractor's capabilities. But we see in relaxing specs, states are starting to relax volumetric properties like voids filled with asphalt, air voids, VMA, voids in the mineral aggregate. Other states are looking at constituent properties like the aggregate gradation or the performance grade of the binder. When we look at the mechanical tests as we set this up, it seems like every state's focusing on rutting and cracking. And so for rutting, we're primarily seeing the Hamburg wheel track test, the ideal RT, and the asphalt pavement overlay, or the asphalt pavement analyzer, and then the high temperature IDT. Along with that rutting, states have picked some cracking tests, the Illinois Flexibility Index test, the ideal CT, the overlay test are the common cracking tests. So when it comes for mixed design approval, what are agencies doing? Well, we see three of these states doing paper reviews. The contractor does the test, they supply the paper mixed design, the state looks at the paper and they approve it. Two of the states are doing full testing. So again, there's not really a right or wrong, there's just different options. So as we go to verification now, verifications from the plant, we're now starting to see the strong trends where states are using that plant mixed lab compacted material. Two of the states require that material to be off the project. Maybe it could be on the shoulder, or maybe it could be mixed from a different state project or a commercial project. Again, state 5 is using the lab mixed lab compacted for volumetric and the plant mixed lab compacted for mechanical. And I'll talk about state 6 in a little while. The relaxed specs for the mixed design approval stay the same relaxed specs for verification. The mechanical tests, here's an interesting observation, is the introduction of a surrogate test. So for mix approval, there has to be the asphalt pavement analyzer and overlay test. But when you go to verification, some tests are a little simpler in terms of specimen preparation. Some tests are a little faster in terms of timing. And so state 5 has gone to surrogate tests for verification, the high temperature IDT and the ideal CT. Now, if one of those were to fail, they would go back to the mechanical tests they use for approval. And here, how does the agency approve the mixed design and the verification? Everybody's doing full testing at this point. This is from the plant producing mix for the project. This is the important stuff that you got to make sure meets the spec, and so states are doing full testing. Here's where I'll just mention state 6. State 6 recall for approval, they just looked at the paper and then they're not doing verification. I will mention that state 6 is getting serious when they do the acceptance, and they are experiencing a lot of disputes. Some of these tests are variable. There's different labs get different results. The equipment changes. It's complex. So I would just encourage a lesson learned, get involved early, maybe even before the approval process, start with some comparison testing to get those tests on board. Now, as we look at the quality assurance program for acceptance, here I'm going to show all 6 states. They all do something different. There's volumetric testing and there's also mechanical testing. So let's start with the volumetric tests. What we see each state doing is testing about the same frequency as they do for their normal projects. We see volumetric testing every 500 tons all the way up to 1,500 tons. And then those quality characteristics of the volumetric tests, what are they doing? Well, most of the states are using them for pay. They're using incentives and disincentives for those volumetric tests. State 5 is using those quality characteristics for action in terms of go, no go. But one state's kind of split. They'll use some of the volumetric tests for incentive, disincentive, and others for go, no go. So certainly a lot of variability in how to address volumetric testing, but it still looks like states are holding on to that in the acceptance process. Again, the mechanical tests, here we see the exact same mechanical tests as we saw for the mixed design verification, state 5 using those surrogate tests. And then what's the frequency? The frequency for the mechanical tests, those range quite a bit from 1,000 every 1,000 tons to every 3,000 or 4,000 tons. I'll mention state 1 here. They're not really doing balanced mixed design for acceptance. They're just checking things sporadically just to see if things are matching or not. So then they're taking no actions. But the other 5 states are using balanced mixed design as part of the acceptance. As we look at how they do that with the quality measure, 4 of these 5 states are just using a single test. So that single test in 4,000 tons or that single test in 1,000 tons is having an action. I should mention that single test is the product of replicates. And so what we're commonly seeing, the ideal RT may have 3 replicates, the ideal CT may have 5 replicates, but that single test has multiple replicates. But nevertheless, it's still a single test. And then the action on states that use it as a single test, we're seeing 2 do disincentives only, 1 does incentive, disincentive, and 1 does a go, no go. Now, state 4, for example, they have 3,000 ton sublots and 4 sublots per lot. So they have a 12,000 ton lot, and they're using an average in order to apply incentive and disincentive. Now, I will say they are running replicates to get these tests, and they also have a coefficient of variation that's applied to the replicates. So that's an example of some strategies and case studies that we're seeing as states start to venture into the acceptance realm. And I'm going to turn it back to Derek at this point for the 4th chapter.
Thanks, Tim. So you kind of saw from what Tim talked about the many different ways that some of the agencies, at least kind of that are leading at this point, how they're starting to dip their toe in the water. And as Tim kind of really hit the point home, you got to kind of see the full picture. What are they doing for mixed design approval? What are they doing for mixed design verification? Often that's kind of, again, first dip into getting into the production realm and then into acceptance. So we've kind of tabulated some challenges and effective practices. And I think what you'll see is that, we've been talking about as an asphalt industry balanced mixed design, obviously for a number of years now. A lot of the work to date has really stayed in that getting a good mixed design realm. I think a lot of it is now going to shift into the necessary items to answer some of the challenges or questions that are there in how to put this into practice further down that kind of continuum down into production, right? As Tim said, it's all part of quality assurance in a way, all right, but bring it further down closer towards paying on it as an eventual goal. So we did take some lesson learned from the lead states, just to summarize real quick. There are differences between what we may be doing now, if we want to just broadly categorize that as volumetric versus balanced mixed design. There are, we're talking about cost benefit analysis. There are resource challenges, right? No matter what the BMD test is, most likely it takes more material and it takes more effort to get a result than many of the things we do today. So there's going to be some presses on resources, etc., that you're not going to be able to necessarily just, add this on, right, to what you have with existing staff, etc. Some other major differences that need to be accounted for in this is, as I kind of alluded to earlier, is that some of these things that we've built our systems around, how we handle our specimens, how we prepare them, our testing protocols, what we do with samples after we take them, how we store them, all right, that has worked for the tests that we currently use. Balanced mix design tests are showing key differences there, where, where most have found that the contractor can test specimens hot, after out of the plant, and the agency could test 2 days later, right? Not have significant differences with many of the things that we do today. Balanced mix design is showing a clear difference there, that, the act of reheating, conditioning differences, specimen handling, and how they're prepared are making larger differences than we're currently accustomed to. So where we've maybe had flexibility in the past, we may need to think about how to change that so that we can match up in between the different parties that are involved in production. Certainly, those of you probably heard me talk about lag and dwell times, right? The amount of time that a sample sits, all right, or specimens sit on the counter. Often this happens to do with, again, reheating specimens, but if they sit somewhere for a while, does that change it? A lot of that work is ongoing through Capri, et cetera. That has impacts here because that's telling you how do I match up between a contractor and an agency, or if there's a dispute situation, right? All of these differences that we may not have to worry about for asphalt content necessarily. Maybe with CT index, we will. All right. Certainly, we've had our previous webinar talked about, aging as testing conditions and the importance of aging. Well, aging takes time in a lot of time, and we often want to get a quick answer, all right, much of the time in production. Again, depending on what the activity that we're doing, QC versus acceptance, the time, press is different, but still there's a need to kind of get answers in a timely fashion, and getting enough aging that gets us a good answer, right? A good valid answer, but also is practical in production. Variability is a big one. All right. Variability, not only in testing itself, but in how we produce mixes, right? That doesn't show up in lab mix. So silo storage time, different wrap, different asphalt supply coming in. How is that going to account? And because again, much of these specs need to be done with a reasonable amount of production variability that is what you're willing to accept and what you're not. All right. And then when you're adding these tests, what do you do with volumetric properties? What do you do with them? Relax, drop, keep. And a lot of that is where the work is now. We talked about the need for maybe something along the lines of measures for consistency in somewhere, because even in those examples Tim gave, the BMD testing has not been able to be as often as the testing that we have now. And that's a concern for risk, right? Based upon sublot size, how often you're getting a test, how much material is that one test representing? So there might be other tests that you keep for a consistency measure in between your BMD results, et cetera. But again, with volumetrics, you're hoping to give some flexibility. That's one of the big, pluses of balanced mix design. Hopefully, that's a big question that, again, I think a lot of agencies, researchers, et cetera, are tackling now that we're kind of beyond some of the initial research on BMD. So key questions that I would almost say kind of ask yourself if you're getting into this way, whether it's with a pilot project, whatever it is, okay? Whose responsibility is going to be mix design approval and verification? Remember, that's a big topic because with BMD, we're saying that a lot of the things, binder supply, wrap, et cetera, that might be different from mix design approval in February versus when I pave it in July. Sorry, I use May months when I think about this. But whose responsibility is that? How is that going to be done? Who is handling mechanical testing? Is it centralized in your agency, or is it done in some regional or district lab? How does that affect down the line how you handle samples, et cetera, testing turnaround time? Again, any production level testing, whether it's go, no go, whether it's incentive, disincentive, et cetera, how is that going to be handled and at what frequency? Often this is a big discussion about throughput. What's the ability? What resources do you have, both at the contractor and the owner level? All right. And how to plan for that additional workload. Because what most have found, at least in the short term, it's going to be more work. Maybe you have to relax back on other things eventually to get back to where you started, but often it's more in the short term. Right? Does the industry, including the state DOT, have the workforce to do that? Right? It's what has been found with the specimen fabrication work, et cetera. The level of care for BMD testing, it doesn't seem all that complicated, but the specimen fabrication, as we highlighted in an earlier webinar, maybe takes a level up. Is the workforce there, or do they need added training? Is contractor results going to be used for the mechanical tests, right? Is the state DOT going to use those contractor results, and how is validation going to be done? Often this can be a challenging because we have fewer results. Often the really good validation kind of procedures need more results to do it statistically, right? To get away from, say, tolerances or things along those lines. All right. Other questions to ask yourself: what are we going to do when it fails, right? Invariably, when it fails, when it passes at mixed design and it fails, what are we doing with those results? How is that going to be handled? Is there any sort of dispute resolution? Is there incentive, disincentive? Is it go, no go, etc.? All right, so those last two bullets, going in and thinking that everything is going to pass, we need to have some plan for when it doesn't. And some of the critical challenges that in putting this together, again, we've kind of looked at and seen for agencies to bring this into production, right? Bring some sort of BMD element to production. It requires staffing and equipment resources beyond just doing it at mixed design. For many agencies and even contractors, that's the case. So evaluating those and seeing what are you capable of, what do you have the ability to do, what can you get for additional resources perhaps, or what are you going to have to do to decide to do what you can with what you have. Identify the roles. Again, maybe go back to basics a little bit on your quality characteristics, on what you are using as quality characteristics, what is good for paying versus action, right? Payment versus action or control, right? There are things that are used in that acceptance environment that you're not necessarily paying directly on, okay? And which ones are good for what, right? Which quality characteristics are good in each one of those roles, right? Creating a sampling and testing plan for your different types of projects, and that's given your equipment, resources, turnaround, etc., right? That obviously is trying to balance risk to sample enough, because we know our materials are variable. We know that, testing it today versus testing it 3 hours from now, it's going to be different, right? We do not have a tightly controlled, production process down to the millimeter, right? That's just the materials that we work with. So creating that and adjusting that as you have needs and challenges. Identify who's preparing and testing samples. All right, just kind of a reminder there that specimen fabrication is really part of the testing procedure. You look in any one of these BMD testing procedures, and specimen fabrication is part of that. So make sure to keeping to proper roles on who's doing what, right? Who's preparing them, etc. Breaking them is that's not the only part of the test. It's making that entire sample. We know that specimen fabrication has a huge impact on the result. And then obviously determining spec limits and a quality measure, which all depend certainly back on your validation, right? But also what you're trying to get out of it. Are you trying to measure variability, etc.? Also dependent on how often you're sampling and testing, right? So these are at least a list of the questions and the things that need to be thought of, right? It's not often, I think, to think about, if you're thinking about a criteria set for mixed design, you may not just grab that value and bring it into production, right? There's these other questions you start thinking about that affect that criteria and those spec limits as well. So all things to think about. I think that the national kind of scale is going to really start tackling a lot of these, and you're seeing more work from those lead states that are getting data and starting to answer some of these. But we hope that some of these takeaways are useful for you to at least frame what does this look like for you, your state, your area, as you venture into balanced mixed design somewhere along the tasks, and think about what does this look like in the future. So as I summarize, and then I'll give it back to Ellie in a moment, we have upcoming webinars, but this is the last one. So we appreciate you attending in our five webinar series where we're talking about quality assurance. And what we're really trying to get here is the idea of quality assurance, getting what you pay for, right? That's the whole idea here. That's why Tim went over all those, again, foundational understandings about what does quality assurance mean, and how are we going to bring balanced mixed design in? How is it different than what we do now? And how does that mean it needs to change our programs and how we do? Finally, We do have the Federal Highway BMD website where Federal Highway is providing a lot of resources through the cooperative agreement. Work with Ellie and everyone in his group, certainly. The workshop that's been delivered many times by Federal Highway. So those resources are still there that you can take advantage of, as well as go back and review those webinars. And with that, I appreciate everyone listening in here today, and I'll give it back to you, Ellie.
Thank you, Derek, and thank you, Tim, for the very informative presentation. Clearly, there's still some work to be done, and perhaps those takeaways and key questions presented at the end will help guide the states as they establish their programs for incorporating BMD into quality assurance. With that, we do have a few questions for you. Start lining up, and maybe I'll start with the first one, and that would be related to the slide number 42, when we talked about the acceptance example from the different states. And the question is, has any state considered starting with an incentive-only approach for tests like the Hamburg wheel tracking or ideal CT in pilot projects? And if not, what your thoughts would be on using such approach to encourage adoption and improve performance?
Yeah, I might just briefly say that from my awareness, I have not seen any state that just uses incentive. There may be some out there, but I have not seen it. But I think that's actually a great idea, for various reasons. State 2 and state 5, they have disincentive only, but another approach, these are just examples. Another approach would be to use an incentive to encourage that. I think that would be a effective practice, a positive practice, and certainly worth considering.
Yeah, and I'll add, Tim, I have heard a couple states thinking about it in the pilot stage, right? You're initially doing a pilot, you're trying to use maybe pilot specifications to get the word out about BMD, get people doing it in production. That's an excellent candidate to, as you stated in the starting stage, just dangle that carrot out there and see if take away some of the risk from the contractor side to get people involved. That would certainly be a good place to start from my standpoint to think about for agencies.
Very good, thank you. The next question is really based on whether the BMD test should be conducted on a plant-produced mixtures or on a course. So if I want to rephrase this a little bit, because I think on slide 40, Tim, you talked a little bit about the approval process, and then some state use, lab makes, lab compacted, plant makes, lab compacted. Obviously, the cores did not come into play in here, but maybe during the acceptance process could be. So how important is basically to understand that difference between lab mixes, plant mixes, and even cores, and then your acceptance should be based on what or which mix type, if you want?
Yeah, that's a good question, Ellie. And I guess I would hearken back to our webinar 2. Webinar 2 out of 5 is on validation. And validation is when you're selecting your mechanical test. You want to select the test that matches the distress you're looking for. And then you want to set a criteria or a threshold with that test that matches actual pavement performance. So when you're running that test in the validation, are you running it on lab mixed? Are you running it on plant mixed? Or are you running it on a core? But however you set up your validation study ultimately needs to trickle down into your mixed design approval, mixed design verification, and acceptance specifications. It's possible to have a combination, I suspect, if you have a rugged validation study, but more often than not, we see people using plant mixed. I think just consistency with validation is what I would say.
Well said.
Yeah. And maybe another variables to keep in mind with the cores is basically the in-place air voids. When you do plant mixes, you have a better control of your air voids compared to core samples.
It's a piece of information, but when you start listing what's different between that and when you start listing the difference between lab mix, plant mix, and a core, the differences aren't just limited to the mix itself, right? It's to other factors, air voids, etc., the binder, right? And knowing that it's a piece of information, but still you got to keep within, you got to try and stick within one sample type in order to kind of rely on it throughout.
Very well. And I think the next questions, if you guys want to also tap on that one, because it seems like to be also related to the validation aspect that you talked about, Tim, about, setting out the threshold, whether it's for mix design or for acceptance. You want to just maybe re-emphasize the validation aspects, and there's no set
Sure.
criteria to use for all states or
Yeah, sure. I think, we've heard a lot of comments like, well, all of our mixes meet this criteria, or none of our mixes meet this criteria. In the end, I really recommend go back to the validation webinar and talk about what real validation and real validation should be, comparison of field sections to these results generated some way for those mixes, right? And so, you could make anecdotal observations to say, well, all of our mixes pass and none of our mixes rut. I've heard that a bunch of times, but that's not real validation. It's still, you want that kind of direct point-to-point comparison as much as possible to have confidence in a threshold, whether it's mix design, whether it's into acceptance, right? Either one, you need that confidence in order to really make balanced mix design work and move it forward.
Very good. And maybe we did touch on this before in the previous webinars, but can you a little bit talk about the reheat aspect of the plant-produced mixtures and how this also might be critical to be factored in as part of your acceptance program?
Yeah, I think many agencies, if you just start with what we do now, some agencies test mix without reheating. They have a presence at the plant. Obviously, the contractor often has a lab at the plant. They test mix while it's hot. And then maybe some owner comes down and takes a sample, it cools off, they reheat it later, they test it. And largely, for the most part, we have systems that can accommodate those two different kind of specimen fabrication procedures for asphalt content or whatever you want. BMD is shown to have significant differences between reheating and non-reheating, end of story, right? You're imparting thermal energy into the sample. It is stiffening, oxidizing, whatever summary you're going to make it, it's changing the result from those mechanical tests. So if you think about an existing state where the contractor is doing quality control, they're doing it that same day as production without reheating, and the agency is taking a sample and they're reheating it and they're testing it the next day, that's where that challenge starts to kind of get in. So again, it's not just plant-produced material, it's plant-produced material that's reheated, or that isn't reheated, or that's aged, right? Whatever that condition is, once you start to step outside those bounds, you're going to get wider differences.
Yeah, and one thing I might add, Derek, I very much agree. That reheating is going to change the mechanical test properties significantly, and states are varied. So some states are more rural, some are more urban, and based on where the plant is set up. One state was, I think, very creative, and they set up a situation that at the time of bidding, the contractor can figure out, okay, do they want to use the reheat samples or do they want to use the no reheat samples? And then based on the contractor selection, the way everything was laid out, they have different criteria. So if there's reheated sample, the criteria is a little, they reheated, the criteria is a little lower. There's no reheat, the criteria is a little higher. Then they accommodate it in that manner just because they have such a diverse amount of paving situations.
And one thing, it's an excellent point, Tim. One thing I just want to add, because we mentioned the lag and dwell as well, that a lot of that work is showing that where's that big concern? It's between no reheating and reheating. That's the big thing, that much of the work, it's not necessarily conclusive, but much of the work is showing that the difference between reheating a box after a day versus reheating it after 2 weeks or something, that those, yeah, some have seen the differences, but the real big one that we know exists is between taking a specimen or taking a sample and compacting it within a half an hour versus letting it cool down and reheating it back up. That's the big difference we know gonna have to account for in some way, shape, or form, or acknowledge it in your program and how you're thinking about it.
Yeah, and not to belabor the point, but going back to webinar 4 of 5, the testing conditions, based on the discussion here, that's a must-see. Sometimes it's not always the most exciting of topics, but it's highly critical in terms of being able to set specifications.
Right. Thank you, Tim. Thank you, Derek. I just posted in the chat box the links to the webinars, to all 4 webinars. And then when the 5th is available, we'll add it to the list pretty soon. Another question here, a little bit from a bigger perspective, is that knowing that both the quality and the quantity of raw materials are important in asphalt mixture, especially in production, right? Do you think like a hybrid approach could be effective, where the focus can shift between quality and quantity control at different stages of the process to kind of better maintain that consistency and performance of the asphalt mixture?
If I understand your question correctly, Ellie, and if I go in the wrong direction here, let me know. I guess what I was trying to highlight earlier is I think that certainly we hope that BMD is the end all be all, and that the pick your tests, pick your 2 tests, and that they're going to tell me everything. I'm not sure that these tests are at that point, right? They're simple enough for us to do in a reasonable time frame that we have to trade off that simpleness with validity, right? That we have a very complicated material, we have very complicated mechanisms of distress, etc. So to me, this is just Derek's opinion, that there's a lot of validity to balance, incorporating mechanical testing. Maybe you can't get it at a frequency as much as you do now, but you use others, what I would consider, am I getting the mix that I asked for? To me, it's not a system that says, give me whatever you want as long as it meets BMD. It's give me the mix design, right? We still want a mix design. We still want a consistent mix design. I want that mix design to meet BMD, but I'm also going to check whether that mix design is what it's supposed to be. Asphalt content, maximum specific gravity, something that's repeatable, easy to test, that we could do more often to give us that confidence in between BMD testing that things are staying the same. It's not perfect, right? But something along those lines. So if I didn't answer the question or went in a completely different direction, then let me know.
No, I think you did great. Thanks, Derek. I don't see any other questions here in the chat box, and we're getting here toward the end of our webinar. Before we let everybody off, we would like to ask you to take a few minutes to again participate in the brief survey that is in the chat box. We will also post for you a QR code. We appreciate your support. It's been for over about 5 months we have been having those successful webinars, and then hopefully we'll see you again early in the fall with our AIEI webinar series. Stay tuned. We'll get you the announcement here out soon, and thank you very much, and enjoy the rest of your day.
And maybe, Ellie, if I just appreciate everyone coming in there. But if there's a comment area on that feedback, if there's other deep dive areas of balanced mix design, we selected these 5 as kind of key ones that we've heard. If there's others out there, I encourage you to take the survey and throw it in there because it would be helpful to know we could deep dive on many different things in BMD and what would be most useful to you. So appreciate everyone attending. If you did all 5, I'll send you a gold star or something like that. So, sticker. So
Good to see you again, Derek.
hey, Rob.
Thank you.
Thanks, everybody.
Thank you, everyone.